Hello, so we're just going to quickly review equations of lines. And in this video, I want to cover slope-intercept form, point-slope form, and then how to deal with horizontal and vertical lines. So slope-intercept form, that's probably the most common form that students first learn, right? Y equals mx plus b. Y equals mx plus b, where of course m is the slope we know. So that represents the slope, and the b represents the y-intercept. And the reason that is if you take a look at this, well, I won't go into slope, right? That'd be a separate thing that we likely already know. But the y-intercept, any point on the y-axis, so you can pick any point you want, the x value of any point on the y-axis is going to be 0. So if I'm here, the coordinates are going to be 0, 2. If I'm here, it'll be 0, 3, so on and so forth. So if you plug 0 into this for x, if you say y equals m times 0 plus b, you're left with y equals b, so you would have the point always 0, b. And so that's why this b value is the y-intercept, and that's going to play into the information we're given. So we're asked to write the equation of the line with slope of -2 and 0.05. The reason this is so easy is because they gave us a point right on the y-axis. So if I was to graph this, I'd have to extend this up just a bit. I would have a point right here at 0.05. And then it says a slope of -2. So of course that'd be, let me scale this just a bit. That would be down 2 over 1. So go down 2 over 1, go down 2 over 1. So we've got this point here that's crudely drawn, I admit, very crudely, that's sloping down. And so the question is, what's the equation of that line? Well, using y equals mx plus b, we already know the slope. So y equals -2x. And then b, the y-intercept was given to us. It's right there on the y-axis, so plus 5. And that, my friends, is how easy it is to write the equation of a line if you're given the slope and the y-intercept. Let's look at some maybe harder ones. Okay, so this one's a bit harder because it just gives us the slope and a point it goes through, and the point it gives us is not a y-intercept. So if I was to just graph this line crudely here really quick of what they give us, just to get a general idea of what it would look like. And I like to do that when I'm working with equations and with anything linear, really. Sometimes it's nice just to put it on a graph, even if it's not neat, just to see what it should look approximately like. So it said the slope of 3, and it goes to the point -1, 2. So it's going to go through this point. And I know 3 is up 3, 1, 2, 3, over 1. So I know I'm going to have a point here. Or I could reverse that. I could go down 3 to the left 1. So down 1, 2, 3, left 1. So I know my line is going to look something like this. Crudely drawn, right? So the question is, what's the equation of this line? Well, I kind of already found the y-intercept just from graphing it. I can see that my y-intercept looks like it's going to be 1, 2, 3, 4, 5. So I'm betting that the equation of this is going to be y equals 3x plus 5. But the question is, what if you didn't graph it? What if it didn't intersect the y-axis so neatly just from using the slope? How would we come to an equation? Well, we can use this thing that's called point-slope form, right? And this should be ringing some bells. So point-slope form looks something like y minus y1 equals m times x minus x1. And all this fancy notation means is I'm going to use the y value of my point here and the x value of my point here. This y is going to stay y, this x is going to stay x. And so if I was going to use this form to derive the equation of this line, I would say, okay, y minus, and then the y value of my point, which is 2, so y minus 2, equals m, which happens to be 3, right? So 3, times x minus the x value of my point, so -1. And as you know, a x minus -1 is the same thing as x plus 1. So I'm going to simplify this to y minus 2 equals 3 times x plus 1. Now I've actually accomplished the goal. This is the equation of the line. But it didn't tell us what form to put the equation in. So what if it asked us to put it in slope-intercept form? Well, I already did that because I graphed it and just looked at it, right? But what if it wasn't so easy? What if it didn't go through the y-axis so easily so I couldn't find the y-intercept exactly? Or what if I didn't want to graph it? What if I wanted to do it all algebraically? So let's just take this algebraically to y equals mx plus b form. So I'm going to give ourselves a little bit of room here. So we have this thing right here, y minus 2 equals 3 times x plus 1. So the next step might be to distribute that 3. So 3 times x plus 3 times 1 is 3. Now you might be guessing what to do next already. Add 2 to both sides. Or not guessing, but knowing. So y equals 3x plus 5. Sure enough, our original equation was right just by graphing it. So this is what we would call, again, slope-intercept. And I'll abbreviate that. Slope-intercept because they show us the slope and the y-intercept. The thing I used before, that y minus y1 equals m times x minus x1, that's called point-slope form. Point-slope form. Because we're given the slope, and we plug in a point. So we've got a point and a slope, and that's where the word the phrase point slope form comes from, the name of it. Now let's talk really quick about where that comes from and why we're allowed to use it. And for that I need all my space. So we know that slope is simply change in y over change in x. And the way to find a change in y or a change in x is to just simply subtract the x values and subtract the y values. So I can go, okay, y minus y1 and x minus x1. Sometimes you'll see y2 minus y1, x2 minus x1. All those subscripts do, all these little numbers right here, y's of 1 and x of 1, that just differentiates between the y. That just tells us that these y's are representative of the y values of 2 points, but they're not the same number necessarily. Or we shouldn't assume they're the same number. And so we know this is what slope is. So I can say m, which we commonly use to represent the slope. I can now come down here and say, okay, so m is equal to y minus y1 over x minus x1. That's a true statement. That's what slope is equal to. And so just a little bit of algebra, I can solve for y minus y1, or I can solve for delta y, for change in y, just by simply multiplying both sides by x minus x1. And you might be already seeing what's going to happen here is these are going to cancel each other out. And so I'm left with the equation x minus x1 times m equals y minus y1. And if I just flip that around as y minus y1 equals m times x1, or excuse me, m times x minus x1, then I've just rearranged the equation. And so this comes directly from, this is all derived directly from the slope equation, or slope formula, I should say. And so it doesn't just come out of thin air. It works because we understand what slope means. And then it's very useful to us if we want to find equations of lines. Let's look at a few more examples to kind of round off this understanding. We're going to look at vertical and horizontal, and I think that'll be a good review. So before looking at vertical and horizontal, there was one more thing I wanted to do. Is what if you're just given 2 points, right? So if you're just given 2 points and they want the equation of the line. Well, one thing you can do, so let's pretend they gave us -1, 3, and I don't know. Let's go with 4. Let's go with 4, 2. So one thing you could always do is graph these things, right? So I'm going to graph -1, 3, 1, 2, 3. I'll go ahead and graph 4, 2. 1, 2, 3, 4. And so I've got this line, and if I was to connect it, and if I was on graph paper, I might even be able to easily figure out the slope just by counting the rise and run. In fact, I could do it without sketch paper right now. That's one way to do it, definitely, and it works. And then once you find the slope, you could kind of maybe even estimate the y-intercept and go right into y equals mx plus b. Or if you didn't want to estimate that, you could just take one of the points and plug it into point slope form, which we know from our last example is y minus y1 equals m times x minus x1. We could just use that. But if we weren't going to graph it, the only extra thing we need to do before we're able to use this formula is actually calculate the slope. So using the points. So if we weren't going to graph it, this is how I would go about doing it. I like to just kind of stack the points actually, and 4, 2. Because I know slope is change in y, or the subtraction of the y's over the subtraction of the x's, instead of using that whole y2 minus y1 thing, and that's great, but I just assume subtracting. So 3 minus 2 is 1. -1 minus 4 is -5. Now these are my x values, these are my y values, so I know my y value needs to be 1, and my x value needs to be -5. So I have a -1/5 slope. And so to get an equation out of this, I can simply take my slope, plug it into point slope form. And then I can take any one of those points. I can take negative 1, 3, or I could take 4, 2, and plug those values in. It doesn't matter what point I choose as long as I'm consistent. So I could use the negative 1, 3 or the 4, 2. And they would both simplify to the same thing because they're both on the same line. It makes sense that they would simplify to the same thing. But just to prove that to you, I'm going to do both of them really quick. So again, I'm going to make myself some more room here. Okay, so let me set up both equations and we'll do them side by side. So we had the points negative 1, 3. We had the point 4, 2. We calculated the slope at negative 1/5. So y minus, we'll go ahead and do this first point here. We'll signify this with red, we'll signify this with blue here. Y minus 3 equals negative 1/5 times x minus negative 1. Let's see if I can get that written correctly. And if I simplify this here, I get, okay, y minus 3 equals negative 1/5 x. Now this is plus 1, so negative. So I end up getting a negative 1/5 on the distribution because it's negative 1/5 times positive 1. And then I just have to add 3 to both sides. So my equation comes out pretty easily here as y equals negative 1/5 x. And then what's a negative 5th plus 3? Well, I know 3 is 15/5, right? So take 1 away, that's 14/5. So plus 14/5. And just to double check that, if you want, you can go negative 1/5 plus 3 is the same thing as negative 1/5 plus, I need a common denominator, so multiply everything by 5, the 3 and the 1, so 15/5. And that's all there was to it. Now let's see if the other one simplifies the same way. So for this one, I'll go, okay, y minus, and I'll go in blue here, the 2, the y value, which equals negative 1/5 times x minus 4. And this should simplify out the same. Y minus 2 equals negative 1/5 x. But a negative 1/5 times a negative 4 is going to result in a positive 4/5. Now I have to add 2 to both sides. Give myself a little bit more room. Adding 2 to both sides is going to end up resulting in y equals negative 1/5 x. And then what's 4/5 plus 2? Well, I know 2 is 10/5. So it's going to result in 14/5 again. And this is exactly what we just had. We had just figured out that this equation, if we had plugged in that other point, was, oops, sorry, I got that weird squiggly white line there, but y equals negative 1/5 x plus 14/5, and we ended up getting exactly the same thing. Okay, on to horizontal and vertical, and then that's it. Okay, so horizontal and vertical. So we know that the word horizontal, I'm reminded of horizontal due to the horizon, right? That was kind of a crooked line. I'm going to fix it. So horizontal is flat, vertical is straight up and down. And so if you're asked to write the equation of something like this, 2, 5, and 2, 3, if you were just to graph those, 1, 2, 3, 4, 5, and 2, 3, you would automatically see, hey, this is a vertical line, right? At x is 2. I kind of missed my x is 2 mark, so I'm going to try and fix that a little bit. And so at x is 2, that's the equation of this line. So that's actually x equals 2 is the only way to express this, because that's the only way to say that x always has to be 2. And any equation of a vertical line is simply x equals some number. And it's going to be a vertical line at that number. Again, this is a review, so I'm not going to go into the undefined slope thing or the zero slope for flat lines, but do keep that in mind as well. So horizontal lines obviously are flat. So if I had a horizontal line here at, say, y is negative 2, that'd be the exact equation of my line. It would just be simply y equals negative 2. So that's pretty much all there is to horizontal and vertical lines. Again, I said this was review, so we didn't go into the slopes or into depth really at all. If you need additional help with this, please let me know, and I'll be happy to provide it. And good luck. Thank you.